So hello everyone and a very warm welcome to today's PV Tech webinar in association with Soltec. My name is Ben Willis and I'm consultant editor at PV Tech. Today we're going to be exploring some of the latest advances in tracker technology exemplified by Soltec's SFOneX tracker solution. It doesn't seem all that long ago that the PV industry was debating whether the merits of trackers justified their additional costs compared to the static racking system that was the industry standard in its early years. Fast forward only a few years, and it's clear that the debate has emphatically been won by those in the pro-tracker camp. According to recent figures from America's Lawrence Berkeley National Laboratory, over 90% of new utility-scale projects in the US incorporated single-axis tracking technology last year, and the picture for other parts of the world is much the same. This is partly because the additional cost of a tracker is more than outweighed by the greater yield it enables a PV project to produce, offering greater bang for the investor's buck. But trackers have become much more than simply a mounting system. And as we'll hear today, the growing sophistication of tracker technology means they've become the brains as well as the backbone of the typical PV power plant. Take terrain, for example. PV is finding its way into new territories where flat sites are either hard to come by because they've already been taken or are non-existent to begin with. Where once this might have been a problem, with tracker systems such as the SFOneX, which are able to adapt to undulating terrain, it's no longer a barrier, potentially opening up a swathe of new sites that were previously unviable. Trackers also play a key role in slashing the time it takes to build a PV plant, with innovations such as pre-assembled componentry and an emphasis on standardization, meaning that trackers can be deployed quickly and a plant generating power and profit far quicker than was the case before. And behind all this are the system's brains, the software and the advanced algorithms that give trackers a range of intelligent capabilities, from maximizing energy production to controlling how the system responds in high wind and other extreme weather events. So to guide us through the many roles trackers play, I'm delighted to welcome our speaker today, Colin Caulfield. Colin is VP of Sales for Soltec Trackers, and he will be taking a deep dive into the SFOneX's expedited installation processes and how these can help slash the costs and boost the returns from solar power plants. After Colin's given his presentation, we'll be opening the floor to questions from you, our audience. And as always, this interaction is really important to us. So please put your questions for today's speaker in the tab on the right-hand side of your screen, and we'll do our best to answer them in the Q&A session after the presentation. So without any further ado, I'd like to hand over to Colin, who will give us our presentation today. Over to you, Colin.
All right, Ben, thank you so much for the warm introduction. And yes, of course, trackers are overwhelmingly the design of choice compared to fixed tilt. So before I jump into the meat and potatoes of the presentation here, I'd like to, I guess introduce myself and also introduce Soltec for those that might be less familiar. So I'm Colin Caulfield, Vice President of Sales for North America for Soltec. I've held this position for about 7 years now, and I've been with the company for nearly 9. And for those that might be a little less familiar with Soltec as a company, we're most well known as a tracker manufacturer and OEM. But interestingly, we are a vertically integrated PV company. We're celebrating 20 years in business this year. We were founded in 2004. What's meant by the vertical integration is that we are an IPP and developer, in addition to being an EPC for those projects that we develop, and of course, a tracker manufacturer. So for projects worldwide, for tracker supply projects, we've supplied our equipment to over 20 gigawatts of projects. And we have better than 93 gigawatts of projects in our pipeline. But as a developer, we're also at nearly 15 gigawatts of projects in our development pipeline. And those projects are throughout Europe and Latin America, with some activity in the DG market in the United States as well. The company has a workforce of better than 1,200 people, and we also have an innovations department that's has nearly 150 active patents. Some of those patents are not even necessarily geared towards tracker products, but rather other ancillary equipment and innovations that are in the PV space that we expect to make a really big splash. But to speak to what is the bread and butter of Soltec's business, of course, we're best known as a tracker manufacturer and an equipment provider. I mentioned that we've been in business since 2004. In 2004, Soltec started out as an EPC, and we were developing, or I should say, we were installing third-party equipment. At that time, we saw a lot of immaturity in this market, and we saw a lot of opportunity for us to design and deliver our own equipment that we were manufacturers. At the time, the equipment that was in vogue, or the equipment that was seen as state of the art, was far different from what we see today. There were dual axis trackers that were on the market. That moved into more of a single axis tracker with connected rows. From there, we also had developments in the space of residential tracker equipment, and we ultimately moved into the utility scale space, where we were providing almost exclusively a two-portrait independent row architecture tracker. That still has a place in our product portfolio. We have the SF7 tracker that is still very relevant. It has its use case for projects that have really constrained spaces and need to pack a lot of power into little space. But where we've landed over the last few years is being a supplier of a single axis tracker that is either independent row or dual row, and is a one-in-portrait configuration. We've recently come out with a version that is specifically tailored to the needs of the United States market, which we call the SFOneX. And what's different about that, rather than the European market or in the Latin American market, is that it's considerably longer. So depicted here on a football field, of course, because it exceeds the length of a football field. The SFOneX is intended to be especially easy and efficient to install, and have the lowest number of components per installed panel or motor. So some of those quick hitters here, we have the longest system, dual row system from Soltec available here is the SFOneX, up to 410 feet. That accommodates many strings, of course. It's flexible. It has a rotary flex shaft and spherical bearings that allow it to adapt to the undulating terrains that you can see on a site, in addition to having a flexible drive shaft in between rows, should the installer so choose to have. The smart power system, which makes it very easy and efficient to commission, and it's compatible with lean installation methods, which is a concept that I'll dive into a little bit farther here. So lean installation, what is lean installation? It's a methodology by which folks can install PV plants going with pre-assembled components and moving in a pattern that is not necessarily tracker by tracker, but moving east-west, and being able to cover as much of the field as possible without having to do any rework or rechecking of torque specs or other checklist items. And we've made our system especially adaptable or especially compatible with that methodology. And before I dive into some of those details, I also want to take a quick look at things like the terrain and the options that we have for avoiding land grading or other cut and fill and costly civil activities. So our system is designed to be able to absorb a north-south slope that is up to 15%, as well as an east-west slope that is also up to 15%, and avoid undulation by accommodating with that flexible rotary shaft that I was describing before. Furthermore, we've made the top of our pile components with such tolerances that we allow for imperfect driving of the W section piles or of the foundations. So what this does is avoid a ton of rejected piles or having to extract piles and redrive them, because the piles themselves can be driven a little bit out of plumb or with an especially wide bump tolerance, allowing us to be able, or allowing the installer to be able to work with the imperfections of the driving of those piles. That is a major time saver and a major cost saver for anybody that's driving piles and installing the system. Moreover, and I mentioned the system of lean installation. We've come up with a way, and this is all driven by feedback from our EPC partners, to deliver our equipment with options to either have things that are pre-kitted, loose, but able to be installed in the system without assembling all the parts and pieces on the field, or having things that nest more easily, much as depicted here in this slide. On the bottom portion here, you see what is a very efficient palletization of purlins, where they all nest together, and it makes the logistics cost really low. But alternatively, as you can see in the image that's above that, we also offer a delivery system whereby you have all of these components pre-assembled but delivered loose. And this applies to our purlins, it applies to our bearing caps, it applies to the drive shaft that goes between trackers, and it applies to our motor assembly, which is pictured in the middle and in the right, respectively. The intent here is that for a group that is intending to not have to basically find, locate, and properly assemble all of the nuts and bolts and washers and componentry that holds the system together, to be able to lay it out in the shakeout process in the locations that it will ultimately be installed, and move in a pattern that goes from west to east and east to west, basically in the most efficient manner possible, from the bird's eye looking at the site as folks move from block to block, rather than installing in a way that is tracker to tracker. Now, the other thing that really enables this is something that's really simple, but it makes the system foolproof, which is having a system of color coding for all of the tubes, all of the purlins, and all of the other components that need to be put into a specific location based on the design of the site. That, as I said, kind of makes it foolproof for folks to be able to just go in a pattern that does the installation block by block, and ensure that none of the parts are installed in a location that is, I guess, out of spec with the design of the site. Additionally, and this is again feedback that we've received from our EPC partners, historically we would deliver material that would come in these boxes, right? And the bolts and the washers and the nuts would all be disassembled. Folks would have to find them all, locate them on site, and they would come in the original manufacturer of that hardware's boxes, right? And those boxes would not be weatherproof, and that often caused a lot of basically a lot of extra trash on the site, and I guess carrying vessels that were not rated to be able to be used in the long term throughout the execution of the project. So we've also started delivering those assembled so that folks don't have to find and locate the correct hardware to go with the other pieces, and doing so in these 3-gallon buckets that are easy to carry, they're weatherproof, and they really make it a lot easier for folks to manage all of the equipment out on the site. Additionally, and again, from feedback that we've received, we've made a few changes to the hardware that we have. It's really important in the US market to not have extra touch points, right? So we were given the suggestion that we should use carriage bolts for anything that can't be pre-assembled, and anything that's going to have a torque spec on site. So the coupler has been adjusted to have inset I guess dimensions that hold these carriage bolts specifically. So on the tops of them, they don't have to be held, and on the bottom of them, they can just be driven without being also secured from the top side. Additionally, we've added little windows so that you can be sure that the torque tubes are properly meeting in the middle of that splice block for QA QC purposes and speed of installation. Soltec has also made sure to achieve compatibility with some of the more popular A-frame ground screws that are on the market. So with APA and with OJO, we've done a lot of work to ensure that we have a system that works with theirs. We've done all the load testing to ensure that folks, if they so decide, they can use these ground screws to avoid a lot of the issues that they encounter on the site. We've seen that they've gained popularity because these ground screws really avoid a lot of the activity associated with pre-drilling and driving, They also avoid even more cut and fill that you would normally have on sites that have undulations, because they have really wide, let's say, surface terrain roughness tolerances. And we've done a lot of work with them and seeing them gain popularity, especially throughout the Southwest of the United States, such that we saw it as critical that our system be compatible with them, because they are more and more the foundation of choice for the market. Additionally, and this is again oriented towards reducing the labor time associated with installing our equipment, we've established partnerships with both Raymond and Vesper Solar. These are groups that make specifically module fixation hardware options. Now, these hardware options do not have a torque spec. They don't have to have a two-piece rivet or a nut, bolt, and washer. They're self-grounding. They work with a friction security system or fixation system. And the other thing, in addition to how much they reduce the amount of labor when it comes to putting the hardware or aligning the hardware between the purlin and the module frames, is that they've been working on having a system that's one size fits all. And this is a really, really attractive option for IPPs and developers as they look at their module supply options, because oftentimes really late stage there's supply chain issues with module manufacturers, and audibles have to be called. So when there's a last second module change, these groups have made different systems that can accommodate a module change without having to go and rework the entire purlin or drill new holes into it, such that we can use the equipment that we already have on the site and just kind of absorb that change without having any additional cost to the EPC or cost to the developer. Additionally, we've made our system very compatible with cab systems. What's being depicted here is taking advantage of the drive line, because our system has either the option to be independent row or to have a drive line that connects rows east and west. And when we connect rows east and west, we also see it as really convenient to be able to have the cab system run the DC collection east-west along that same drive line. This is something that's space that's already been used. So we see it as just a natural place for us to put that, and it's not going to, I guess, change the accessibility of the site during the O&M phases. This, however, is not a requirement. There's lots of other ways that you could set up the wire management. We have folks that do it along the east-west corridors, running on the north or south end. Of course, you can still do a traditional trenching, but we find this to be the most cost-effective and most attractive option that we can put out there as far as saving on the EBOS for the system. Additionally, we have a smart power system. This incorporates a couple of different things. One is the power itself for the trackers, which is driven by an auxiliary panel, which then powers a battery, which can be up to a 12-amp battery. And this battery is dimensioned to be able to have available power for up to 4 days, even if it's not receiving any additional energy. So again, they're very site condition dependent, like how cold is the site, how much light should it expect to see in the summer versus the winter months. But the design intent here, again, is that you'd have up to 4 days of power without even receiving any additional light from the sun or charge to the battery. Additionally, in that same box that hosts that battery, we have an open thread full wireless system. Now, this system is designed to have a path of least resistance that communicates all the way to the gateway cabinets and have a really robust connection that is not subject to any type of risk of failure or miscommunication. Additionally to that, it's a very easy system to commission. It's self-commissioning effectively. So what used to take our system, or maybe having a high end of 3 to 5 megawatts per day that we could commission is more than doubled with this system, which is great. All right, and so having spoken to some of the things that make the installation easier, I also want to get into some of the algorithms that we've developed. Now, some of these algorithms are designed to protect the assets from harm, and some of them are designed to optimize the amount of yield that you can get on a site. Starting with the former, we have several that we've designed that are specific to certain types of hazards. Wind is probably the one that we've put the most time and effort and have the most history with. Snow is another one that is a hazard, and we have a certain type of response to it. Flood, likewise, and then hail. Hail is probably the one that has been most spoken about in the industry lately. I'll get into each of those, or I'll especially touch on the wind and the hail, because those are probably the hottest topics and the ones that asset owners want to be sure that they have adequate protection against. But addition to that, there's other safeguards that are on the site. So there's a button that you can go up to and just actively press to stop in case you need to manually stop the system from tracking. There's also other automatic controls, such as a low battery notification that will cause the system to go into a stow and protect itself from wind or other types of harm. There's overcurrent protection also. So if the tracker is tracking into some type of obstruction, the overcurrent protection kicks in and doesn't allow it to continue to damage the equipment. But to start with the wind, we have a methodology that we developed that's called DieWind. And this is a methodology that we co-developed with RWDI. RWDI is a wind consultant firm that's out of Guelph, Canada, and they are responsible for some of the tallest skyscrapers, some of the longest suspension bridges, and some of the other critical infrastructure that is subject to, of course, real-world conditions and all types of gale force wind conditions. And so they helped us design not only the individual tracker and how we calculate its behavior, because it is a dynamic structure in several different conditions, but also the entire plant, because not every tracker within a power plant is exposed to the same forces. There are interior rows, there are exterior rows, and our collaboration with them has influenced everything that we have learned, so as to be able to have a plant that is safe from any type of harm, but of course, not over-designed such that you're designing with a lot of extra steel and leaving a lot of money on the table, so to speak, right? These methodologies have also been peer-reviewed by CPP Wind, which is another highly regarded, highly respected wind consultant here in the US market. And we've gone through several experiments that have our trackers installed in places such as the NREL facility on the Front Range in Colorado, where it is in real-world conditions exposed to not only wind tunnel tests, but also real-world high wind conditions, right, that are in excess of 100 miles an hour. So the point being, or the takeaway from this, is that asset owners should rest assured that our system has been tried and true and is very capable of being designed such that they're saving as much money as they can, but of course their assets protected from harm. The other main topic that's about asset protection is our algorithm we've developed for hail protection. Now, there's a couple of main topics here. There's what does the system respond to, and then there's how does it respond. And this is more novel. You know, these are it's been increasingly a problem for the PV industry, but it's not as it doesn't have the same experience as wind, right? And so what I'm getting to there is the jury seems to be out on how systems should respond, and our system is designed such that we can make ourselves accommodate the insurance provider's requirements. But before I get into that, there's also what it's responding to. The best way for us to approach this is to have a mixture of an on-site sensor, which is a precipitation sensor, which would know, if you're seeing rain or snow or hail. But before getting to that point, also having prediction software with which our system is communicating and responding to. So if there is hail that is very obviously and high likelihood in the forecast, our system can preemptively stow against the hail to protect it from harm, should that onset of hail come, rather than responding in the moment. Now, So that's sort of like a redundancy or a way of double or cross referencing, you know, the prediction with the actual. Because the other part of this is we also don't want to be stowing unnecessarily for really long periods of time, because of course there's a production loss that's associated with that. But to go back to what I was touching on before and speak to how our system responds, the obvious thing to do is to put the system at some form of stow, right? Some higher stow angle. The intent here is that as hailstones are falling from the sky, they're not making a direct strike against the surface of the glass, right? Or a perpendicular strike that is likely to cause harm to the PV module. Now, the things that are configurable, of course, are what is the angle of stow and what's the direction of that stow. As a standard, our system will have a wind stow that's up to 55 degrees. So the steeper you are, the better off you are, because the less likely the hailstone is going to fall out of the sky and hit the PV surface or PV module surface directly. But in addition to that, there have been some sites where the insurance requirements were, or I guess it was noted that the wind behaviors when there was hail was also that there would be a prevailing wind direction. And so one thing that has been asked of us is that our system can face away from the wind or be receiving the wind from the backside as hailstones are also falling, to further ensure that there aren't hailstones that are basically riding the wind right into the perpendicular surface of the front of the module. And so we've been able to develop a system that can have an operational wind speed that's in excess of 60 miles an hour and be receiving that wind from the backside to further ensure that it is increasingly unlikely that any hailstone would do anything but graze the surface of the module and further protect it against harm. Aside from algorithms that are intended to protect the assets, I mentioned before that there are some that are designed simply to optimize the gain that we have or optimize the yield. So Team Track is one of those algorithms, and Team Track is our ability to have backtracking that is not perfectly in sync or is asymmetrical intentionally, with the purpose of avoiding the inter-row shading east to west. What this achieves is that in the early part of the day and in the later part of the day, you're avoiding the losses that are associated with those with that shading, and therefore increasing your bell curve to have more energy in the early and later part of the day. Now, the way that we achieve this hasn't been with sensors or anything like that we view as subject to failure or subject to basically misinformation being given to your plant. Because they have to be in specific locations. We've decided that it would be more effective to go out to the site and do an as-built survey that would look at all the equipment on site and determine, with this tracker's height and distance relative to its neighboring trackers, there's an obvious position that it would have on a certain day of the year, time of the day, to avoid shading its neighboring trackers. So we pre-program that into each individual tracker controller box, and we don't depend on anything changing or any sensors malfunctioning so as to have that functionality day in and day out throughout the course of the year. This is a system that has also been verified by TUV Rhineland. It shows about 6.2% potential for the high end of the yield gain over standard tracking. This, of course, in a situation that has a high amount of undulation or incidence of shading. But point being, we're able to maximize plant's potential by having this capability. And another similar type of algorithm was designed specifically to address the issue of diffuse light. Now, it was determined a long time ago, or it's standard industry practice or understood, that when you have diffuse light on a PV plant or anywhere, you are better off, or you collect more energy if you have the trackers stow at a flatter angle, or basically stay at a flatter angle, to collect more light from all directions, not specifically looking perpendicular at the arc of the sun throughout the day. Now, we did more experiments and more tests, and this again was verified by TUV Rhineland that we can have gains anywhere from 5% to 6.5% roughly, depending on the location and the incidence of diffuse light at a certain location. Basically what happens is, much like the hail sensor, there is a diffuse light sensor and there is prediction software that are intended to be redundant and confirm that we're going to have diffuse light for an extended period of time. And that gives a command for the entire plant, or whatever applicable part of the plant, to go to stow to maximize the amount of energy gain that you would get on the system, instead of simply following the sun throughout the course of the day. We again view this as critical to have the corroboration, right, between the prediction software and the sensors, because we don't want to be effectively chasing clouds and having the system yank between following the sun and being in some type of diffuse stow. So these are all part of our standard package. These are not additional things that we sell. There's only the cost of having the sensors themselves and the software that predicts the diffuse light conditions. So most cost-effective way to maximize the energy on your plant. And with that, I'd say Ben and the team from PV Tech, thank you so much for the time and the space. And I don't know how much time we have for questions. I hope I didn't run over too much.
Thank you very much, Colin. That was great. Really insightful tour of the many capabilities of the SFOneX. I always find that a little bit of a tongue twister to say that, but anyway, hopefully I've got it right. That's brilliant. Thank you. So we come to the interactive bit, where we'll take a few questions. We don't have a lot of time, but we've got a few that have come in. So
sure.
I think one that's probably going to be of interest to particularly our audience from the US is one around the domestic content policy. So obviously the use of domestically manufactured content is a hot topic in US solar currently. So I was just interested if you could talk a bit about how Soltec's trackers are affected by the domestic content rules there, and how it's meeting those obligations under the policy.
Yeah, thanks for the question. I mean, how we're affected, it's really just that the market is moving towards requiring, or at least asking, the tracker providers to provide steel steel components that are made domestically. However much percentage of the tracker product you can make, the more that you can make with domestic manufacturer, the better, right? Because then that puts the customer closer to achieving the IRA compliance, which of course gives them a tax incentive, right? Investment tax incentive. So on our side, by the way, Soltec is a group that likes to provide piles when we can. We don't have to. It's a part of our scope that is itemized. But for IRA compliance, it is required that the piles themselves be US sourced. And so we have a number of folks that have availability for the W section piles that we provide. And then as far as the other steel componentry, there is tubes, and there are purlins, there's hardware, and there's other componentry like the splice blocks, couplers that bring the tubes together. Now, we have contract manufacturers that are stateside to roll all of that equipment. We have it for our 2-portrait system. We have it for our 1-portrait system. And it's really just a matter of how much of the system can we, I guess, what percentage of the system can we achieve, right? And so if we do all those steel components that I mentioned, for which we do have contract manufacturers ready to go stateside, we get to a little bit better than 70% of the overall product. Some of the other pieces of equipment, motors, gearboxes, electronics, those are imported, but there have been efforts on our side to also bring some of that stateside. We're looking for suppliers for gearboxes, for example. We've been talking to some folks, and that will increase the proportion of stuff, of equipment that we're bringing over stateside, in addition to having an assembly line for our electronics. Which can be achieved. We've historically done that in Spain and controlled that in our manufacturing facility in the southeast corner of Murcia, Spain. But that's another step that we'll be taking to increase that proportion of domestic content.
Great, thanks for clarifying that. We've had a few sort of follow-on questions from some of the stuff you were talking about
Sure.
with regards to sort of extreme conditions. I'm just going to try and sort of wrap a couple of those together. So one was how your tracker reacts when there's high wind and a power outage on site, and what does the algorithm do in the case of flooding? So two separate questions there, but sort of related.
Yeah.
So I'm wrapping them up.
So the trackers in the gateway cabinet don't depend on the AC power of the plant. So if there's power outages that are outside of that, it's unaffected. The point being, the system still has power from its batteries, so as to be able to communicate with the entire system and give them commands, right? Like based on the anemometers that we have tied in that we also supply, that gives the necessary information to protect the asset. So that's the short answer. I don't know if I missed some part of the question, but it's basically just independently powered.
Flooding there, flooding, that was the other bit.
Flooding, yeah. So flooding, what you would want to have is a sensor that would be looking down at the, from the tracker, looking down at the flood plain. And of course, like this is configurable. It depends on the site conditions. But the point being, as water or whatever is accumulating below it, you would want to be sure that the tracker system stows. Now, the other thing to pay attention to here is that it has to stow at a high angle, right? So if you have a floodplain that's especially high, you also have to raise the tracker system up higher because it needs to be at a high tilt angle in the event that there is a flood, but there are also wind hazards that are present on site.
Very good, thank you. Again, a couple of related questions. We've only got time for a couple more, but what plant capacity would you recommend your tracker for in terms of cost benefit ratio? And related question, what would you consider the smallest megawatt peak installation?
Fair. I mean, so the smallest plant for which I've provided trackers, I want to say, I mean, I'm not going to count test facilities because that's kind of its own category, but we have done a plant that was 2 megawatts DC. That's not our target, right? And it's not where we can be most competitive, I should say. Generally, we focus on those plants that are 20 megawatts and greater. But I see all distributed generation plants that I see, they're still designed with tracker systems. The economics of it still makes sense. The gain that is associated with trackers is somewhere between 20 and 30%, depending on, location and myriad other conditions. So, there are economies of scale. The tracker does get more aggressive as you get to higher volumes. But I'd say generally we play in a space that is 20 megawatts and greater, but I have supplied to systems that are as small as 2 megawatts DC.
Great stuff. I would say, for the installer EPC community, there's nothing quite like sort of getting your hands on the kit. So I wondered whether you might have anything to say about opportunities for installers to have a go, maybe in the US, where can come and get some hands-on experience.
Yeah. So we have a facility that's in Tumble, which is just outside of Houston, Texas. This is a place where we have a warehouse that's a hub for having a lot of our extra equipment on hand, being able to deploy spare parts. But in addition to that, there's a field where if folks want to get familiar with the equipment, they can come out there, disassemble, assemble. They can practice different methodologies with parts that are pre-assembled, as I was describing, to really understand how they want to install it and how we recommend based on best practices that we've seen. So really, if there are folks that have that question or a desire to come out and put the system together, I'd encourage them to get in touch with me, and I can connect you with our team that's out there, where we have construction experts that have built both our 2P and our 1P system countless times and can give all the advice, both in a classroom setting and in a hands-on out in the field training session.
Great stuff. I think we've got time for one more question about labor. Whether you could talk about labor savings. I mean, you talked about your lean installation method, which I guess ties into this question.
Yeah.
Just to give us a sense of, I guess, what sort of time savings are associated with your.
Yeah, I mean, the numbers that have been thrown around at me were that, you know, the installation labor rates were about 200 man hours per megawatt. Now this has changed, and that's the thing. We recently worked with a group called Eclipse M, and they're going to give us new numbers on that. But the point being, depending on which EPC and what methodology they used, that's more or less the average that I've been seeing. And how you reduce the man hours and the labor, really, I was intending to expose that in my presentation. Some of those fixation hardware methods that we have, or the groups, both Raymond and Vesper, have done a lot of work that turn the module installation into just seconds time per module, being able to clip those on without any, you know, need to fumble with a nut, bolt, and washer. The pre-assembly of the kits that I was describing really make all of that far less labor, because you don't have to painstakingly assemble all that componentry and put together all those nuts and bolts and even find the equipment, right? Because historically it had been delivered all separated in separate components, and folks that were installing it had to locate, kit, etc. It was an extra operation that was on the plant. So all of those resulted in in great reductions in labor hours. And then of course, like the avoidance of any cut and fill, the avoidance of civil works, all of that is labor hours, right, that we're avoiding. And equipment. You could have equipment that you avoid having on site entirely. So not only the man hours that you have to pay for, but the rental equipment that you would have to, or if you own the equipment, the use of that equipment that you'd have to bring out to the site to be able to execute is entirely avoided. And that's really the crux of what you need to do to decrease the installation costs of the system.
Great stuff. Well, thank you, Colin, so much. We are out of time. Judging by the number of questioners who've asked whether your presentation will be available afterwards, I would say it's gone down pretty well. So thank you very much again. And in answer to those who've asked, yes, the event has been recorded and will be available on demand on PB Tech in a few days' time. And the presentations will be shared by email. So you'll be able to go through those at your leisure. So that brings us to the end of this webinar. I hope you found it stimulating and informative. I know I certainly have. All that remains for me is to offer a huge thanks to Soltec for sponsoring this webinar, and to Colin, of course, our presenter today. Contact details will be available on the presentation you receive for any follow-up questions. So I hope you'll be able to keep the conversation going. So that's it from us. Thank you all very much for tuning in, and have a very good rest of your day. Thank you.
Great. Thank you, Ben. Bye-bye.
Bye-bye.